I'm Adam Shostack. I'm a program manager with Microsoft where I do an awful lot of work in threat modeling. And I want to talk today about elevation of privilege, the easy way to threat model. And why do we need an easy way to threat model? As security experts, we've all learned how to threat model. We have an understanding that you think like an attacker and you take a system apart. And we've all learned how to do this really well, right? But if you go to a normal developer and you say, think like an attacker, what they hear is much like me telling you to think like a professional chef. You have no idea how to put together a dinner for 500 people, how to budget. And so telling people to think like an attacker isn't a complete solution. As we roll out threat modeling to normal engineers, it turns out that it's really, really hard for them to do. It requires this security mindset, which we here at the conference have, but which a normal engineer, I was talking to someone who said, I don't need security. He was telling me about this conversation. I don't need security. I'm using magic quotes. Awesome. Magic quotes, it's a feature in PHP which somewhat makes it harder for certain subsets of some attacks to work. There's another issue. When you're a developer and you're working really hard on this feature that you care about and you've spent months and months getting it to work, getting it to perform, getting it to be reliable, it's really hard to give up that view of what it is that you've created and look at it from a different perspective. This is why when you write a paper, you hand it to someone to get edited. This is why we separate dev and test into different roles, because this creator blindness exists and needs to be overcome. And then there's these really intense consequences for errors or omissions. And so this all leads to one very natural conclusion. Let's not ask developers to threat model, which is a great conclusion, except developers know something that we as security experts don't know, which is they know all of the ins and outs of what they're building. And because they know all the ins and outs of what they're building, they're in a really great position to threat model if only we can help them do so effectively. And so, when we used to go out and train developers to think like an attacker, it didn't work so well. So over the last few years, we've really improved the way we train people to threat model. We've improved our tooling a lot to work better, and I want to talk about two ways in which we did that. The first is the SDL threat modeling tool. This is a free tool from Microsoft, and it makes the main goal is to make threat modeling flow better for a broader set of people. And the way we did this is pretty simple. We made it simple. We made it prescriptive. We included a lot of self-checks. So when you start out, you start by drawing a picture of the software you're building. In software, we all draw pictures. So the developer knows how to do that. It gives them feedback about the picture they're drawing for threat modeling purposes. And it's right there on screen with them. Second, it guides you through analysis of threats and mitigations using Stride. I'll talk about Stride in just a second. And it integrates with bug tracking systems. Now, if you think about it, I've got 20 minutes here. Why am I telling you this thing integrates with bug tracking systems? It seems like an odd point to mention, but the reason I'm mentioning it is because a development shop that ships a lot of software handles bugs. Developers know how to handle bugs, and so by outputting bugs from a threat modeling process, instead of having a document which sits on the shelf and gets forgotten, you've got something that the developers deal with on a day-to-day basis. The bugs are where, the threats are where they're going to go to find them, which is the bug tracking system, and that helps you get them fixed. So, the Stride framework, Stride is an acronym. It stands for Spoofing, Tampering, Repudiation, Information Disclosure, Denial of Service, and Elevation of Privilege. I say that a lot. And these are the opposite of properties that we want. And it's a great framework. If you want to think about what goes wrong and you think, how is someone going to spoof this? How is someone going to tamper with this? This can help you remember the sorts of things you ought to go through as you're looking at a system. But it's a little high level for a normal engineer who's not a security expert. And so This is a screenshot from the SDL threat modeling tool. We apply the various types of threats. For example, spoofing applies to external entities, things outside of your control. So does repudiation. All 6 stride threats apply to running code, to processes. Data stores, tampering, information disclosure, and denial of service. And we've got a bunch of stuff here, so I'm not going to focus on it for too long. But what I want to point out is that what we do is you've drawn a diagram. It says, here's this data flow called results, and it's subject to these threats. We put this information directly in front of the user to make it easier for them to understand. Then we've got guiding questions for them to look at. Those expand out. More and more information is on screen. So this was a dramatic improvement. We made threat modeling a lot better. But what we discovered when we went out and talked to people who were using this tool inside of Microsoft and outside is that what threat models got a little boring. It was pushed to one person, so there was less collaboration. There were fewer perspectives. Sometimes threat modeling was pushed to a junior person on the team. And then when we had meetings to review and share threat models, a lot of times a single expert would drive the meeting and say most of what was being said. Instead of having working meetings to develop the threat model together, there were review meetings to look at what had already been built. And I wanted more. I wanted the different perspectives. I wanted to see different people chiming in with their views. I wanted to encourage participation from all sorts of people. I wanted to give people an opportunity to push back against an expert who said that's not a big problem, or we should look somewhere else. And so what I developed is Elevation of Privilege, the threat modeling game. And this is inspired by work on Protection Poker by Laurie Williams and the whole serious games movement. And my goal was to create a game which is simple, fun, and gets people engaged and into this flow state as they are threat modeling. So serious games is a real field of study. There are academics who spend their careers in serious games now, after a guy named Clark Abt wrote a book on the subject in 1970. And he said serious games are games which are played primarily for a well-defined educational purpose. They're not intended primarily for amusement. And there's all sorts of things here. There's tabletop exercises, there's persuasive games, there are games for health that teach you to eat better. And there's been a whole bunch of work at Microsoft, which I'm not going to delve into here today, but in Windows 7, the language quality game was something that we used to actually find language issues in the translations before the product shipped. And it was a tremendously successful way to draw people in, to use 5 minutes of their time, to look at a dialogue in a language they spoke that wasn't English, and point out bugs. And I'll talk in a few minutes about why it was successful. So, Elevation of Privilege is the easy way to get started threat modeling. And in the next couple of minutes, I'm going to tell you what you need to know to play it. So you start out by drawing a diagram. As I've said, everybody draws diagrams in software. It's easy. Then you take one of these card decks. These card decks are available online. They're a free download. And they have threats on them in 6 suits. They're based on the stride threat. So you have cards in spoofing, in tampering, in repudiation. And you deal these cards out to people, and you play in hands. You go around the table. And each card has a threat. So, for example, the Queen of Repudiation says an attacker can say, I didn't do that, and you'd have no way to prove them wrong. And so the way you play is you connect that threat to the diagram. You say, aha, there's no logs that show the transactions that take place. You give people a point for playing that card. You stay in the suit that was led, and you play through the deck. Oh, and as you go, you take notes. Who found the threat? What it applies to? So let me walk you through an example of how this actually works. So this is a training system that we use. It's basically a tripwire-like system where there's an admin console. There's an admin console down here. An administrator runs it. There's some result data. or about the configuration, and it sends commands out to the host software on a variety of systems and gets integrity data back. So if we're going to play Elevation of Privilege, Alice might lead and play the 3 of Tampering. And the 3 of Tampering says an attacker can take advantage of your custom key exchange or integrity control, which you built instead of using standard crypto. Now, as security folks, we know that's bad. As a player, you might say, oh, well, yeah, we're doing that. It's not a big deal. But you're pulling the issue out. You're literally putting it on the table and saying that's going to apply here and here. So next, Bob might play the 10 of Tampering. And the 10 of Tampering says an attacker can alter information in a data store because it has weak ACLs. So we know that, or the developer might know, that that applies to that data store down there because they haven't set ACLs on it, or they needed to modify them to make some test run, and they never switched it back. So Charlie might play the 5 of Tampering. An attacker can replay data without detection because your code doesn't provide timestamps or sequence numbers. And that might apply there. Finally, Dan would play the 8. The 8 of Tampering says an attacker can manipulate data because there's no integrity protection for data on the network. We know encryption isn't enough. We also need integrity controls. So some rules: you play in suit if you are able to. The high card is going to win the hand unless there's a trump card, an elevation of privilege card. We encourage brainstorming through aces. The aces say you've invented a threat not in the deck. And then you give people a point for each threat and a point for the hand. So after you play, you finish up, you count points, you declare a winner, you give them a little toy or something, and you file bugs. And we've seen this work for teams inside Microsoft, and we've seen it work for some folks outside who have been kind enough to give us some of their success stories. So shifting gears a little bit, stepping back from the game, that's the game. It's working. It's helping people threat model. Why does it work is an important question and one that I want to talk about. The first reason it works is because it's attractive and cool. We went out, we hired a little graphic designer, and people see these and it looks cool. It looks fun. And that's in contrast, frankly, to a lot of times when the security team shows up with their checklists of stuff that you've got to do, and you know this is going to be a painful meeting, or the person across from you knows this is going to be a painful meeting. It looks like fun, and that draws people in, it opens them up. It encourages flow. It encourages people to get into that engaged state that you get when you're playing a game, when you're doing something which is worthwhile and engaging instead of something that you don't understand and don't want to be doing. It requires participation. The threats on the cards are here to act as hints. If you've got a set of cards laid out in front of you, you don't have to think of what's a spoofing threat. You can read the cards that are there and say, I think this one might apply. And that's a whole heck of a lot easier than coming up with something out of whole cloth. So there's also instant feedback. You read the card, you say, does that apply? People agree or they disagree. And then you move on. It's not, you've got a whole bunch of people, they're doing the threat model off on the side, and then they discover they made a mistake, they wasted 3 hours doing something incorrect. The game gives you social permission to be playful. And this is really important. The work we do is important, it's serious, there are consequences.